Question 18. The ratio of the number of boys to girls at a party is 3 to 4. 6 boys leave the party. The ratio of the number of boys to girls changes, and it's now 5 to 8. Work out the number of girls at the party. So this is quite a challenging question. The ratio has changed, but despite the fact that 6 boys have left, it appears that the ratio has got bigger. It's gone from 3 to 4 to 5 to 8. So, to do this, we need to sort of have a bit of understanding about how ratios work. So, if we think about at the start of the party, the ratio was 3 to 4, okay? And this is boys to girls. So that means there could be 7 people at the party, where 3 of them are boys and 4 of them are girls. Or it could be that there's 14 people at the party, and there were 6 boys and 8 girls. If we then think about towards the end of the party, when people leave, when the 6 boys leave, it changes, so it's now 5 to 8. So again, that could mean there's 13 people at the party, and there's 5 boys and 8 girls. Or there could be 26 people at the party, so we need 10 boys and 16 girls, and so on. So if we continue these down, we need to find a common factor of both the 4 and the 8. Not a common factor, a common multiple rather, of both the 4 and the 8. Because the number of girls has to stay the same throughout. So let's continue this and I'll show you what I mean. So this pattern here is going down in 3, so I can just finish this, continue this a little bit more. Okay, let's stop there. I'll continue if I need to. The other side is going down in 4s rather than 3s. So 4, 8, 12, 16. So I find it easier doing it individually, because otherwise you've got a bit too much going on, especially in the exam when you're getting a bit stressed. You might end up making a mistake. Right, do the same for the other ratio, so 15, 20, 25, 30, and so on. So this one's going down in multiples of 5. So what I'm doing is essentially working out all the possible number of boys and girls that could be at this party using these equivalent ratios. This is multiples of 8, so 24, 32, 40. So, if we think about it now, I've listed every possible, or up until a certain level anyway, of number of boys and girls in order for it to have these ratios of 3 to 4 and 5 to 8. So, we know the number of girls would have to stay the same. Okay, so for example, if we looked at these two ratios, 6 to 8, that's one possible combination of boys to girls that we could have at the start of the party, because this simplifies to 3 to 4. Remember, 6 boys leave, none of the girls leave, at least not that we're told, and therefore, there could be 5 to 8 girls by the end. All right, but actually, we've only gone down by 1 boy so far, and we know 6 boys leave, so we know it's not this one. But that's just an example. So if we continue looking down, we look for the next pair. So this one here, for example, also seems to work because we've got the same number of girls. Okay, so if we look here, we've gone from 18 boys down to 15. So only 3 boys have left the party, and we want 6. So it's not this one. But actually, because 3 is half than 6, maybe if we double this, that would work. So let's have a look. If we double this one, take us down to 36, and double that one gives us 30, and look, the girls are the same. So let's have a look at this in a bit more detail. So there could be 36 boys at the start of the party and 48 girls. Then 6 boys leave, so that 36 reduces by 6, so it takes us down to 30, and the number of the girls stay the same. So we look like we've cracked this one. It says work out the number of girls at the party, so the girls is the second number, so it's 48. There are different ways of doing this question. I found that listing it out like this was more logical to me, and I understood what I was doing more than using other methods.